Hello, this video is for final project presentation of EE538 in USC, and this project is finished by the collaboration between Xinlei Yu and Yisai Wang, and I am Yisai Wang. Now I'm gonna introduce the summary of this project. We finished all of these functions in this project. First of all is autocomplete. As you can see, I input the partial letters of the location name, which is CA, and the results show that all of the outputs with the name starts with CA. And below you can check the time taken by this autocomplete function. Next is find the location. We have two cases. The first of all is we spell the location name correctly. I input the target and the output shows that the latitude of and longitude of target. And now I replace the E with O to simulate the case of typo, and the result will correct the name automatically. And we input Y here to confirm it, and the result will show the latitude and longitude of the correct version. Next is find all location categories. For this function, we have no input, so the function will just simply output all of the categories in this TrojanMap. Next is get all locations of a category. We can pick a random category got by the function 3, and I choose closest here. The results will show the IDs of this location which are in the category closest. And next is get location matching regular expression. For this case, I use the TA.plus, which is regular expression of these two names, tab to blue and target. The result will show the ID of these two names. And next is I'm gonna introduce the shortest path. For this function, we use the two different algorithms. First of all is Dijkstra. As you can see, I input the start location routes and destination Bank of America. The results consist of IDs of the paths of the locations which are visited by the path. And the last line of result tell us the distance of this path. And you can also check the time taken by Dijkstra algorithm. And the next is Bellman-Ford. As you can see, the result is completely the same as the last algorithm, Dijkstra. Also the distance of this path. By displaying the result on the map, we can compare it with the real-time Google map. And the solutions are similar, which can verify our function. And a running time comparison between two algorithms, and the time taken by Dijkstra is much less than the Bellman-Ford. So based on the actual situation, we need to select these two algorithms very carefully.
Hello, my name is Xinlei, and I'm going to present the rest of part of the fellow project. For item 7, we made a cycle detection for the TrojanMap, and we gave a sample input, and within the given bound, there is a cycle inside of the bounds. For the item 8, the topology sort, we have a sample input. We have a few location we want to go, and from the result we see we want to start from the Ruffles, and then we go to chicken fillet, then we pass by Bank of America and Kentucky Fried Chicken, and then we go to Target, and the last we go to Cover. Pardon me. We go to Cover first before the Target. Here we have arrived to the phase 3. And for the traveling salesman problem, it's very well known NP hard problem in computer science. And we have a few approach to solve this very difficult problem in theoretical computer science. Here we have a example input with number of the places as 5. It's pretty quick that the algorithm can solve it within like very, very quick of time. And we increase the number of the places to 6. And we see it take a little bit slower than 5 places, but still quick enough. Then we see if we increase the number of places to 7, the problem can be solved a little bit slower than number of the places as 6. So we can conclude that the time complexity for the traveling salesman problem goes like some sort of like exponentially increase with the number of the places increase. Here's like a small demo like we have for the previous problem. So for item 10, find nearby, we have a example input. So we want to find the market near the target, and here's the result. For the item 11, we want to find the path to visit all the places. Here's the input and output we have, and it's pretty good way to. It's kind of like a shortest path, but we do visit multiple places in the between, and if the input size is increased, like it's gonna the runtime complexity will be like super high, like exponentially grows. So what we learned from this project, also from the EE538, we had a lot of experience using Git and Bazel. For the GitHub, we kind of have a collaboration between 2 teammates. It's very good development tool for version control and so on. We also learn a lot of useful algorithm, and we do implement those like digester and Bellman-Ford. We also learn a lot of data structure and graph theories. We also did learn a lot of programming techniques like dynamic programming. Also, we did implement DFS backtracing. So it's very good useful courses, and we also have a lot of practical like a homework and project that we can implement what we learn from the course. So that's conclude what we have for this presentation.